Hi, and welcome back to our third lesson in this unit. So tomorrow in class we're going to do some activities that will tie into this, and we'll just start with our notes here. So congruence, what makes two things identical? Twins, fingerprints, Miley Cyrus, Justin Bieber, who knows? Pins when you're bowling? Well, some things are not exactly congruent. Two or more geometric shapes are congruent if they have the same size and shape. Look at these triangles below. Decide which ones you think are congruent. If you said these four, then you're correct. Remember that they could have different orientations, rotations. They could be flipped, known as reflections, or translations, which means they're moved around. But these would be the four in this example. Congruent statements. This symbol here, the equal sign with a little tilde on top, or a little squiggly, means congruent. Again, same size and shape. So we see these two images here, triangle ABC and triangle FED. Right? So when writing a congruent statement, sides and angles must be written in a corresponding matching order. Now, it's far more important that your angles are the matching order here. The sides is kind of more of a convention. We list all known corresponding matching parts of the two triangles above. So take a minute to do this. Write the corresponding matching sides. So here I have it in words, and what it would look like. If triangle ABC is congruent to triangle FED, then, arrow meaning then, side AB is congruent to side FE. Notice AB follows this direction, FE follows the same direction. So we try to keep that convention. Side BC is congruent to side ED, side AC is congruent to side FD. And then we talk about the angles. Recall that I said that you only need to use one vertex if there's only one angle that forms at that point. So angle A is congruent to angle F, angle B is congruent to angle E, and angle C is congruent to angle D. Theorems and properties. So given two triangles, triangle ABC and triangles DEF, notice that we can see here that this marking in angle B is the same as this marking in angle E. Angle A has the same marking as the same marking as angle B. So that tells us that those two are congruent. The third angle theorem tells us if two angles in a triangle are congruent, then the third angle is congruent. So remember, if I take 180 minus A minus B, I'll get the remaining angle. 180 minus D minus E, I'll get the same remaining angle. Recall that our triangles are 180 degrees, and that's something that's consistent for us. The reflexive property of congruence. A quantity, line, angle, congruent object is congruent to itself. So what that means is when we're completing proofs, we can use a distinction between two different shapes. For example, for any triangle ABC, AB is congruent to AB. It's congruent to itself. Symmetry property of congruence. When a quantity, line, angles, or congruent object, they mirror each other. Right? So we can get that idea of mirroring. If triangle ABC is congruent to triangle DEF, then triangle DEF is congruent to triangle ABC. So right, we see that they mirror each other. Again, being consistent in the order of vertices. A, B, C follows the same order of vertices, D, E, F. The transitive property of congruence. For three segments or angles, if two segments or angles are each congruent to a third segment or angles, then they are congruent to each other. So triangle ABC is congruent to triangle DEF, and triangle DEF is congruent to triangle JKL, which is in here, then we can conclude that triangle ABC is congruent to triangle JKL. So we think about using this property to allow us to make connections between things that don't have a direct link. Proving congruence. This is where we're going to start to get the idea of writing informal proofs and then move from there to our formal two-column proofs. So if I want to prove that triangle ANC is congruent, so here I have ANC, is congruent to triangle BND. So again, N is my same thing in both of these in the middle here, so I kind of list that order. Angle A is 45 degrees. Measure of angle NCD, right, is given here, is is 30 degrees, or NDC, excuse me, is 30 degrees, and angle A is congruent to angle B by the markers, and angle NCD is congruent to angle NDC. So what can we conclude from this? Well, let's look at the first thing. Since angle D is congruent to angle C, then angle C is 30 degrees, right? Then I could say 180 times 2 times 30 degrees, and that will give me angle CND as 120. So that's our triangle sum theory. I could fill this in. It's good to fill in your diagrams as you're working. So I have a 30 degree angle here and 120 degrees, and thus making 180 degrees. Angle CND and angle ANC form a straight angle, meaning it's a straight line. So anytime you have a straight line here, what we could say is that together this makes 180 degrees. So since this is 180 degrees, 180 subtract 120 leaves us with 60 degrees. Right? Over here. Angle ANC and angle BNC are vertical angles, right? And put your arms up and form an X, and that's the idea of the vertical angle. Therefore, ANC is going to be congruent to BNC, and they're both 60 degrees. See how the diagram we're filling in as we go. Since angle A is congruent to angle B, and we already know that angle A is 45 degrees, therefore, or then, angle B is also 45 degrees. And then you might be thinking already, right, I can go back to what I know about triangle sum theorem, or the third angle theorem. Since angle A is congruent to angle B, and angle ANC is congruent to angle BND, therefore 180 minus 60 degrees minus 45 degrees leaves us with 75 degrees. So each triangle is always going to be equal to 75, or equal to 180 degrees, and we can use that to get to that 75 degrees there in both of these triangles. Therefore, it proves that triangle ANC is congruent to triangle BND. So we must present all this information in here when we're talking about, and we also must be able to talk about what theorem or postulate we're using to support our evidence. This takes us specifically to our first postulate, side, 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 known as the SSS congruence postulate. This postulate states that if three sides of one triangle are congruent, same size and shape, to three sides of a second triangle, then the two triangles are congruent. So we look here at triangles ABC and triangles RST, and we want to prove if they're congruent. So again, make sure that the order of vertices is corresponding as we work through this, and we can see that the tick marks match up for the corresponding matching sides. Side AC is congruent to side RT. Keeping the order, side AB is congruent to side RS, and side BC is congruent to side ST. That's enough information, once we've proven all three sides are congruent to each other, to go in and state, using this postulate, that triangle ABC is congruent to triangle RST. If you can think it, you can prove it. And we'll continue with more postulates in our next lesson.